Hello friends, welcome back to the channel. Today's chip need not be a smaller one, but it needs to be smarter and it needs to be faster to handle the workload. Now we use chip from smartphone to self-driving car. The more the complexity in the chip, the more workload the chip needs to carry out. So in today's video, we'll talk about how real world AI chip is designed. AI is required to carry out this heavy workload required by today's chip. So we'll talk about how real world AI chip is designed. In today's video, we'll talk about what is the AI technology behind this. We will talk about different top chip design companies who are enabling AI to design their chips, and also AI is evolving, so it is not something constant. So every day, every month, every week, AI is evolving, new algorithms are being introduced. So we'll talk about all of this in this today's video. Stay tuned. So what are the workloads that AI chip needs to handle? Let's talk about this. So first of all, it needs to handle large data. So as you know that more and more data and information are available in today's computing. There's all these things needs to be scanned and needs to be calculated and computed. So AI chip needs to be faster to handle all this large data. Now to handle this large data, it needs to be having a extreme speed, because if it is slow, then it does not serve the purpose. So speed is also required for the AI chip. And the happens is that when AI needs to handle a large amount of data and it needs to carry out with extreme speed, the chip becomes very because of the compute friendliness, it becomes very consumes a lot of power or energy. So that is something whenever we do kind of any kind of work, we do some Google search. A Google search can enable you to lamp a bulb. That much of amount of power is required. And in ChatGPT also, whatever we do the processing, that requires a lot of power from the chip itself. Those are the AI chips. So it needs to be energy efficient. So we'll talk about AI chip needs to handle large data. We talk about extreme speed is required. Then it requires to be energy efficient. And also most importantly, it needs to handle parallel processing. Although today's chip is basically customized for a particular task to be carried out, but AI chip also can handle general tasks or generic tasks, I would say. So parallel processing is required so that parallelly it can process multiple tasks, so that overall the efficiency of the chip improves. And most importantly, when we do a processing, we need to access memory. So it needs to be faster in the memory access. So all these features and attributes are required for an AI chip to handle the today's workloads. Now let's talk about the real world example and the top chip design companies who are using this AI technology. First start with Intel. Intel has a latest node that is 18A. 18 is basically representing 1.8 nanometer and A is basically the angstrom era. So this is the latest technology that Intel is working on, and they are planning to do a mass fabrication by the second half of 2025. Now what are the technology behind this 18A? It has major two technologies. One is basically the ribbon fed. This ribbon fed technology in 18A node is basically surrounding, it's a gate all around transistor. So gates are surrounded by the four sides of the transistor. So this improves the overall chip performance by 15%. And the next is that the power via technology. Power via is basically providing the power to the chip at the back side of the chip, so that you can open out the more space for the layout. So obviously it improves the chip layout stuff by 10%, or you can say that improve the efficiency by 10%. So these are all about the Intel 18A technology. Now let's talk about some other companies like TSMC. TSMC is something they are working on 3 nanometer in the production, and in this 3 nanometer they are also working on the gate all around technology out there. 2 nanometer is something they are already doing R&D, and the latest thing is basically they are also started thinking of the 1 nanometer technology as well, but this is something take maybe 2027. Till then we are not getting 1 nanometer technology, but they provide chip for the Apple A series, they provide chip to NVIDIA, and also the AMD CPUs. In the NVIDIA GPUs is basically the TSMC chip out there. Now let's talk about Samsung. Samsung is basically the fast among all the technologies in the gate all around transistor, but they are little lagging behind this TSMC, but still they are working on 2 nanometer, 1.4 nanometer, at least at the R&D phase, and but they are doing the plan for the production of this by 2027. Next we talk about NVIDIA. NVIDIA use TSMC technology, TSMC chip, but they are also relying on the chiplet. Chiplet is basically the small chips that do individual functionality, and they combine in a group so that it improves the parallel processing, and also you can put multiple small chip in a same substrate. So all these companies are doing research on the AI stuff, and they are doing production, they are doing R&D. Something 2025 they have some planning, and then 2026, 2027. So it's basically something you can have a good traction of all these chips. Now let's talk about how this AI chip is designed. The first component is basically, there are 3 components. First components I will talk about, that is a machine learning. Machine learning are used to optimize power, chip power, and optimize performance. Second thing is that reinforcement learning. This is something part of the artificial intelligence. This is the algorithm. So this reinforcement learning is heavily used to chip layout. Maybe in some other videos I may talk about in more detail about machine learning and reinforcement learning, but not at this scope of discussion. The third thing is basically the simulation and the modeling. The simulation and modeling are used, which predicts the chip behavior even before the chip is being manufactured. So these are heavily used during the chip verification process. So these 3 things are being primarily used by the AI technology itself. But the thing is that, do we know enough of AI? Do we know artificial intelligence enough so that we can have traction and we can do, as I talk about that companies are doing, they are planning for the latest technologies in 2025, beyond 2025, 2026, 27. But the thing is that they are also doing some research, because every node, it is not a mature node. Mature node means that you have the older node which are matured, you have enough proof that there are a lot of yield has happened, lot of chip has been manufactured with this node. So these are the new nodes, the yield is less, and so they will get matured with time. They will have some issues in the fab or the fabrication of the factory. So that is the rollback of the chip. So all these incidents will happen. So that's why AI is evolving. They are continuously doing research on that, and based on that they are improving the AI algorithm to make more robust AI chip. Now we talk about a lot about this AI chip. So what is your thought about that? If you are an electronics engineer or you are on the chip designing side, which actively you either on the transition, or you are already into the AI modeling of the chip, or you are a verification engineers who are thinking of that how technology can be used in the chip verifications. So please drop some comments in the video, so that that can improve the interactions between what is you are thinking of and what I am thinking of while giving this talk. And most importantly, the thing is that overall AI is helping every part of the thing. So it is helping in the chip design, it is helping in the chip verifications, it is helping in the chip fabrication process also. So today's video is dedicated for the real world AI chip design and how the latest chip designing technology is being used in the top chip design companies. So let's do a recap of that. We talk about why AI chip designing is important, what is the heavy workload, what kind of AI is contributing in the software, AI is contributing in the hardware. So by the way, if you think about AI applications, AI is now used in the large language model training. So ChatGPT like things are also using huge AI chips to train their language models. So we talked about also that how AI can be trained, and also the real world examples, like we talk about Intel technology, Intel 18A technology, TSMC 3nm, 2nm technologies. We talked about Broadcom, we talked about Samsung, we talked about NVIDIA, and also we talked about what are the three different ways this AI chip is being trained. And last but not the least, we talked about AI is also evolving. For example, Intel also started working on the 14A technology, which is a further improved technologies. They also have 18AB, what is a power optimized version of 18A. So all these innovations are happening around. So I hope that you like this video. So if you like this video, please subscribe this channel, and also press the like button, and share your comments in the comment section of the video. And last but not the least, I just want to share that I have published a book called Semiconductor for All, that is basically having 25 fascinating topics on semiconductor and artificial intelligence. So if you are interested about semiconductor, if you are interested about artificial intelligence, what is happening around, so I would suggest that you please purchase this book. I will provide the book link in the comment section of the video. So wait for the next video to come. Till then, Subhasish Chakraborti signing off.